Good morning, everyone, and welcome to the UBRI Connect 2023. I'm Anchal Malhotra, and I lead the research team at RippleX. It's truly an honor to have you all today here as we set on to explore the innovation in finance and the transformative power of blockchain technology. For the next 30 minutes, we'll be talking about and delving into a topic that is not only at the heart of this conference, but is also a subject that is changing the landscape of traditional finance worldwide. That is on-chain finance. And today we have the privilege of having one of the experts, leading experts, and thought leader in this area, Professor Don Song. But before we delve deep into this conversation, let's all make sure that we are on the same page, what we mean when we say on-chain finance. In essence, on-chain finance, it basically represents the seamless integration of blockchain technology with traditional finance, thus offering a decentralized, transparent, and more secure alternative. And with this seamless integration, it opens up doors for a host of opportunities ranging from decentralized finance to tokenization of assets and much more. All right, so next, let's dive deep into it. Welcome, Professor Don. First off, you are leading research on-chain finance and have been leading one of the most popular DeFi massive open online course with hundreds and thousands of lecture views worldwide. So would you like to start by telling our audience why you are so excited about on-chain finance and why you think it's important?
Great, thanks a lot. And first of all, thanks a lot for having me here. And again, thanks a lot for the UBRI support. I wouldn't repeat what people have just talked about earlier. Definitely, I think the UBRI support is really important for supporting academic research in this really important space. So now let's talk about why I'm so excited about on-chain finance. So first, let's look at traditional finance. What the traditional finance do and how they do it, and then we can talk about how on-chain finance solves many of the problems in traditional finance. So traditional finance is about the process of creating, management, and investments of money and financial assets. And when we talk about financial services, they do a lot of different things. For example, banks and the various financial institutions, they can take users' deposits, they do lending, borrowing, they provide various financial, different instruments and manage funds, insurance, and so on. So all these are different financial services. And in traditional finance, they are all done essentially in the same way, which is that they are all managed by centralized parties, run in the centralized services. And they all handle essentially custody of users' assets. So actually, for example, the banks actually has users' money, and also in this case, the user's money is a number in the bank's database. So from this perspective, you can see that first of all, these banks have, these financial institutions have to be fully trusted since they are handling, they are custodying users' assets. And also for every transaction, essentially users, if I want to pay you money, we cannot transact directly. We have to go through these financial services. And they essentially are the intermediary, so they can decide whether we can actually transact. So they could censor transactions, and since they are the intermediary, they'll take a fee, and that's rent-seeking. And also the centralized financial services, they are running these really opaque, siloed databases, this kind of proprietary systems. So the whole thing is very closed. It's very difficult for a third party, for example, startups who want to provide new financial services to actually interoperate. So it really stimulates innovation. And also, as I already mentioned, the key thing is that because they are custodying users' assets, they are in the middle of everything, these intermediaries, so they have to be fully trusted. So, and hence, yeah, there's a lot of inefficiencies as well. So these are the issues of traditional finance. So now let's talk about on-chain finance. So on-chain finance is done in a completely different way. Whereas in traditional finance, we have to, it's run by fully centralized, fully trusted parties. With on-chain finance, it's actually done in a very, very different way. It's, these are financial services that's built on top of this public smart contract platform, built using completely open, permissionless a protocol stack that actually enables true interoperability. So because of this, the on-chain finance offers a lot of advantages. So first, I mentioned traditional finance. The financial institutions actually are custodying users' assets. Whereas in on-chain finance, actually users take self-custody. So I have my private keys, and hence I hold my, my financial assets with on-chain finance. And also, because the on-chain finance is done completely in this open, permissionless way, it's very inclusive. So first of all, anyone can use these on-chain finance services, and there's no intermediary, so there's no rent seeking, and it's done in a fully decentralized way. So there's no, it can be censorship resistant. No single party can censor the transactions and so on. And also, because it's open, it really enables true interoperability. So as a startup, for example, if you want to build on top of these open financial services, it's very easy. The code is open source. All the APIs, essentially, the smart contract APIs is right there. So you can just write your application, and then you can deploy it. So it really, it really speeds up innovation as well. And with this on-chain finance, essentially that's what we call programmable money. So now, also with the smart contract capability, you can really fully program, put in various policies or functionalities that you want to enable these financial services. So the list goes on and on. And also, as I mentioned, because there is no intermediary, then it's much more efficient. Right, so really,
trustless,
exactly,
it's inclusive,
right?
So all the advantages.
So all these great advantages. So that's why I'm really excited about on-chain finance. That's why I led this massive open online course on DeFi and have done a lot of research in the space. And also, I think in practice, what we have seen is also really speak to the speed of innovation and development. If we look at on-chain finance from when it started to when the TVL total value locks went up to hundreds of billions of dollars, it's only a matter of a few years. Whereas in traditional finance, you can imagine the path would be much, much longer to actually go from zero to to where it's
innovation is really fast in this world. So
exactly. And also, given its programmability and all these advantages, in on-chain finance, actually, there are new services that you actually cannot build in traditional finance. So, for example, flash loan is a very good example where applications can borrow money without any collateral or anything, a huge amount of loans within the application, just within one transaction and so on. So, so these are really, again, like I said, the list is very long. So these are just a few points why everyone, I actually do tell students at Berkeley and other students at meeting other places, really everyone should learn about on-chain finance.
Amazing, thank you. Yeah, thanks for this bigger picture. But as you said, there are a lot of advantages to on-chain finance. But I'm sure let's now narrow down our focus on some of the challenges, some of the research areas that you're pursuing, and a lot of attendees here are pursuing some of the research areas that are really pivotal to the success of on-chain finance. So first up, guess what? The classical duo of privacy and security. I think no one can deny that these are the absolute must-haves for financial applications. So would you like to tell our audience some of the latest innovations in blockchain research that can enhance privacy and security of on-chain finance.
Great. Yeah, it's a great point. It's a great topic. So again, so first we can look at the contrast. So in traditional finance, actually, the financial services, they are required to have certain onboarding and compliance and continuous compliance requirements. So actually, for a user to become a customer of a financial service, you need to go through like KYC, and also there's AML. So know your customer and anti-money laundering, this kind of regulations and requirements. So as a consequence, the financial institutions actually know, essentially they know everything, right, about the user. They know the user's real identity. They know, of course, the user's assets and all the transactions and so on. So there is essentially very little privacy in this case in traditional finance. Because, again, the service providers knows everything about the user. So when it comes to on-chain finance, it actually offers a great opportunity for us to actually build something that has much stronger privacy guarantees. So for example, in this case, we can actually use advanced cryptographic and security technologies to ensure that, so essentially, when you look at this on-chain finance, so first of all, you want to make sure, okay, you do hold this much assets. Nobody can take away your assets. And then when you transact, for example, once I pay you, for example, $100, then accounts are modified in the correct way, and so on. So these are the functionalities and logics of the financial services for payments and for these different exchange, for example, decentralized exchange, and so on. So on one hand, essentially, we want to have integrity, meaning that we want to make sure that these financial applications or transactions are done properly. But on the other hand, we want to provide privacy as well, so that, for example, nobody should know what accounts I hold and how much money is in my account. And also, when I send you $100, there's no reason for anybody else to know that I send you $100, as long as the account balance are modified correctly, so that when I send you $100, it's not like my account still has the $100. Then we'll have a problem in this in this financial system. So the next thing is that in cryptography and security, we've made huge advancements in these technologies, including zero-knowledge proofs and also other types of secure computation technologies, so that we can actually build new protocols and applications that has this guaranteed, has these properties. So for example, with zero-knowledge proofs, I can do the transaction, I can send until $100, but without actually anybody else knowing that is the case. And at the same time, so then you may ask, then how do you do this? How do I know that, since I don't know who sends until $100 and nobody even knows until got $100, how do you make sure that the financial system still works properly? So in this case, I actually create what's called these zero-knowledge proofs. So these are mathematical proofs using cryptography to actually show that, in this case, my account actually has decreased $100, and Andrew's account has increased $100. And these proofs are done in this case called zero knowledge. Zero knowledge in this case really means that nobody else actually knows the details of the transactions, but it's a mathematical proof actually being able to prove to third party in this public setting that this has been done correctly. So this is an example showing that in this on-chain finance setting, in this decentralized setting, we can actually use these advanced cryptography technologies and mathematical tools to really enable these type of new properties.
It's actually incredible, because one of the guarantees of blockchain technology is anonymity or privacy, which is at odds with the regulations and compliance. But technologies like ZK, zero-knowledge proofs, they kind of bring together the best of both. You can get pro-compliance privacy, let's say, is the term.
Right, exactly. So that's a very good point. So zero knowledge proof, the history of using this to enable privacy in payments in financial services has been done for a number of years now, starting from zero cash, Zcash, and also recently many of you may have heard about like a Tornado Cash, and that actually brought a lot of controversy and issues. In particular, how do we want to ensure both regulation compliance and also at the same time, privacy. So again, right, as Ancha mentioned, so zero knowledge proofs actually it has a lot of flexibility and has great power. So you can actually enable what we call compliant privacy,
right,
or controllable privacy, meaning that I can generate a proof showing that I'm sending Anchal $100, and also at the same time, I can generate a proof showing that Anchal's address is not on the blacklist that nobody should be sending money to. So this is also a great example where using these more advanced technologies, we can enable actually both privacy and regulatory compliance.
Awesome. Yeah.
And also just briefly adding a little bit more. So zero knowledge is a great technology for enabling this privacy in financial services. However, these mathematical proofs can get expensive. It's expensive to compute.
And that's one of the challenges that you're working on, exactly.
Exactly, right. So my group and, of course, lots of other researchers in the space have been making a lot of progress. I would say the progress in zero knowledge proofs field has really been exciting and astonishing, both from theoretical innovations as well as in practice, the improving the engineering aspects for making these zero knowledge proof systems, proof generation, proof verification, more efficient and practical. I've almost never seen any cryptographic fields that has seen such fast and broad improvement. So with that said, for complex computation, it can still be expensive. So hence there are some other methods. There are trade-offs for different trust models. So some of you may have heard about using, for example, secure hardware, like secure enclaves. It uses a combination of hardware and software solutions together to ensure that the certain computation is done in a confidential way within this hardware secure enclave, such that no other, for example, operating systems, applications running outside of the secure enclave can know what's running inside. So in this way, it's another way to provide privacy so that you can actually run the entire financial application inside the secure enclave. And in this case, you can actually run much more complex financial applications with essentially close to native performance. And so Oasis Labs actually has been doing work in this space as well. And also, I do think that in the larger scale financial services, we are going to see more adoption of this type of secure computation technologies as well.
Great, yeah. Thank you for that. My next question would be interoperability. Well, we all know it's a key to the success of blockchain networks, especially when we think about multi-chain future. But there are, I think all of us have heard a lot of attacks, specifically on this critical aspect, interoperability. When we talk about bridges, we've all heard about millions of dollars being stolen just because of the insecurity of bridges. So my question to you is, how are researchers looking at this specific challenge, and are there any groundbreaking advancements in this field?
Great, yeah, thank you. Great question.
And this is something that we are closely looking at RippleX as well.
Right, great. Yeah, thanks. Yes, talking about bridges, interoperability, essentially you want to enable application on one chain to be able to know the state of another blockchain. and hence, essentially, the bridge helps helps the two chains communicate in this case. And yes, you mentioned about a lot of attacks on these bridges. Essentially, really, if you look at blockchain applications and services, bridges is by far the biggest attack target. And like billions of dollars have been lost due to attacks on bridges. And when we look at how these bridges are attacked and why they are not secure, a big reason is if you look at how traditional bridges are done, they are actually done in a more, they have a lot of trust, like they are trusting these
committees.
Right, so either they are trusting, usually they're just trusting a small number of nodes to operate the bridge. And hence, it really offers these weak points for attackers to compromise. So once attackers compromise just a few of these nodes, then the attackers essentially can compromise.
So is it the lack
bridge.
of decentralization that you're saying?
So exactly. So in this case, there's a lot of trust in these small committees. And ideally, given the ethos of what we just talked about for this on-chain finance, what you really want is to have fully decentralized trust. You actually want to build trustless solutions. So that's actually a recent work that we have done. The first solution building fully trustless bridge that's fully decentralized that we call ZK bridge. So I just talked a lot about zero-knowledge proofs. So besides enabling privacy in financial application services for on-chain finance, actually the same technology, zero-knowledge proofs, can also be used in this case for building fully decentralized trustless bridges. So in this case,
Could you explain for our audience what you mean when you say trustless?
Okay, yes, great. So in this case, so for example, when we, for the bridge essentially needs to, when a transaction happens on one bridge, the application on another bridge needs to know, for example, a transaction has happened on the other bridge. So essentially there are messages that needs to be sent from we call the sender bridge to the receiver bridge. And you need to ensure that this message is not spoofed, it has not been modified, it's actually this true transaction that has happened on the sender bridge. And so in the traditional setting, you have for example, you have a small number of nodes operating the bridge. For example, they can sign, each of them can sign a message saying that a transaction has happened on the sender bridge and send the signed messages, transactions to the receiver bridge. So in this case,
You're trusting this committee to not...
So the receiver chain needs to trust this small set of nodes that they have signed the right messages to state that the correct transaction actually happened on the sender chain. So then the question is, how can we remove this trust? So with zero-knowledge proofs, then the idea, so in this case, we're actually not using the zero-knowledge part. We are more using just in this case, a succinct proof.
Right.
That essentially a prover, anyone in this case actually can be the prover. The prover can actually generate a proof proving that actually this transaction has happened on the sender chain, and then sends the proof and together with the information about the transaction to the recipient chain. And the receiver chain, on the receiver chain, there's what we call updater contracts that can then actually verify the correctness of the proof.
So the trust now is in the math versus
cryptography
versus on a small...
Right, in a small number of keys, that's actually signing the right messages.
And the ZK part here is not important because privacy is not what we are looking for. It's the snarks, like the succinct proofs. It's about the efficiency, like we can generate these trustless proofs in an efficient way.
And then the verification can be done very, very efficiently on-chain.
Right. Great, awesome. All right, I have a lot of questions, but in the interest of time, let's move to something that I don't really want to miss out on, and that is something that's all of us probably are really excited about, and that's artificial intelligence. So we know that AI and ML are being integrated into various industries. Do you think that we can leverage AI for enhancing on-chain finance in any form? And if so, could you give our audience some examples of practical applications?
Absolutely. Yes, I think AI is on top of the mind for probably everyone here. Who hasn't used ChatGPT, for example, in the audience? Raise your hand. Okay, we do have a couple hands. Okay, maybe you want to try after this, after the session. So yes, these large language models we see really they have these really astonishing, enormous power in terms of what they can do, and similarly, this power actually can be applied for on-chain finance, and actually in many different aspects. Here I'm just giving you one example in using these large language models to improve the security of on-chain finance applications. So we've done a few pieces of work in the space. So as one example, one work we did recently is called Block GPT. So what it does is that we actually built a large language model on the transaction, essentially the execution traces of these transactions for these on-chain finance applications.
To monitor these transactions.
So yes, so because there has been a lot of attacks on these on-chain finance applications, so it will be very helpful to try to, in real time, detect whether an application is anomalous and hence may be a malicious transaction. So in this case, we build these large language models trained on many, tens of millions of transactions, execution traces of these transactions, and essentially model these transactions, how to execute, and so on. And then when in real time, when there's a new transaction, we can try to essentially assess how likely the execution trace is, and hence knowing whether this transaction is anomalous. So we have been able to get actually amazingly good results using this. So we look at over 100 different on-chain finance applications that have been attacked, and our results show that close to 50% of them, we can rank the anomalous transactions among the top 3. We can rank the malicious transaction among the top 3 most anomalous transactions in the entire transaction history of these of each of the essentially these victim applications, and hence gives really high accuracy to identify malicious transactions in this case.
That's I guess that's pretty promising result. Is it in any real production environment? Have you talked about it?
That's a good question. So right now it's still a research prototype, but yes, we are very excited to discuss with different on-chain finance application developers and to help detect these anomalous transactions. And so that's one example. Another example is we have been exploring using these large language models, for example, GPT-4 and so on, to investigate smart contracts and to try to pinpoint vulnerabilities in smart contracts and so on. And they have shown they can be pretty good. There are still a lot of challenges. They can give a lot of false positives, but potentially they can really help auditors to significantly reduce their manual auditing time.
Awesome, yeah. That's really fascinating. And we only have 1 minute, so what do you want our audience to take away from this? And what do you think about the importance of academic collaboration with the industry? And what would be one advice that you want to give to the developers, entrepreneurs, and researchers who want to get into this field of on-chain finance?
Great. I think I truly believe that in order to make advancements in this important field, we really need to bring together academia and industry. So that's why UBRI is such a great forum and platform to bring together industry and academia. And And I think that there are many different types of collaborations that we can explore. Again, I think many of these have been done in UBRI, which again serves a great example. So for example, recently, also Berkeley led, the Berkeley RTI led the another MOOC, Massive Open Online Course on Zero Knowledge Proofs. And that we've had.
That could be a very good starting point for anyone who wants to learn more about it.
Right, so we had a great global participation. And together with the MOOC, we also did a hackathon where we had hundreds of teams globally participating in the hackathon. And that also gave a great experience for in the collaboration between academia and industry as well.
Bringing theory to practice.
Right. So for example, as part of the hackathon, one of the teams in the hackathon actually from my university actually worked on a ZK Bridge, a prototype implementation
for XRP Ledger.
For XRP Ledger, actually was one of the winning teams as well. So I think this is a great example how industry, academia come together to make advancements in the field.
Awesome, and we are right on time. So thank you so much, Professor Dawn, for sharing your invaluable insights.